Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hello, and thank you so much for coming to this call today and talking with me.
Right.
Just to sort of start off, could you briefly introduce yourself as well as walk us through your academic personal journey to sort of get you where you are today?
Yeah, so I'm Varun. I'm going to join the third year in the undergraduate maths course at Cambridge. I guess in terms of personal journey, I kind of knew I wanted to do maths for quite a long time since I was maybe 12 or 13. Um, so I guess it was all quite streamlined. I just did maths at school and then did some extra maths and then applied to uni and then now I'm doing maths at uni. It's not a particularly special or inspiring story, but yeah.
What's sort of like the math major experience like at your university?
Yeah, so I definitely think there's a big difference between the UK and the US, or maybe Europe and the US, in the sense that there's my impression so far is that there's a bigger emphasis on depth in the UK versus in the US. So really, the Cambridge course is very specialized, very intense. I actually think that maybe I've learnt less. Less quantity of maths compared to people at other universities, but except in Cambridge, it's just done to such an extreme level of detail and precision and rigor that I think it's very narrow. And that of course is a good thing or a bad thing, because if your aim is to go into industry or something like that, then maybe it's good to have a broad experience in STEM. But I certainly think the Cambridge course is designed to churn out pure mathematicians or applied mathematicians, and so you end up with quite a narrow view. So I think yeah, in the first year, excuse me, yeah, in the first year you had to do 8 courses, so it was 4 per term, and then the third term is for exams, and then that was on a broad range of things. So there was a bit of pure maths, a bit of applied maths, a bit of theoretical physics. But then by the second year, you sort of narrow a little bit. You decide what courses you don't want to do, and then in the third year, that's when you just go crazy and do like super specialized things. So I guess in my case, I haven't really. I mean, I'm going back in a month, so I really should have figured this out by now. But I don't have such a clear idea of what I want to do, what I want to specialize in. But I know it's definitely in the realm of pure maths, and it's probably going to be either combinatorics, probability, or maybe number theory. That's sort of where I'm at the moment.
And I was just wondering, like, after going through such like an intensive math curriculum, what sort of like opportunities, like job-wise or like career-wise, would you have available that you're like currently interested in?
Yeah, so I think one of the downsides of Cambridge is that I don't think it's actually particularly helpful when it comes to careers, in the sense that there is a lot of outreach that goes on, in the sense that I always get emails about careers fairs or sort of events which are being held by various companies, and you can sort of go to them and chat with them. But I don't think the university necessarily really care about your career choice per se, right? They just want you to do well on your degree. Um, by contrast to at school, where I went to a school where there was a lot of help from teachers in terms of university applications and so on. So it seems like more of a vested interest there than there is over here. And I think I've sort of lost what was the question you were trying to. Oh, what sort of opportunities after the Cambridge course, right? Yeah, so I think really, uh, if you talk to most people doing the course, they'll either have one of two plans. Either they're going to go into finance, so quant finance, investment banking, whatever, right? And then work in the city, make a lot of money, whatever. Or the other option is to become an academic and do research and so on. So really, when I think about my own future, those are the two paths that I'm kind of having to decide between. Although I think that it's what you often forget doing maths is that it's actually there are actually a lot of soft skills that you develop as a mathematician, which is applicable in any career, right? Like perseverance, discipline, attention to detail, precision, so on. So I think I often think that people who are doing a maths degree or are interested in maths should try to look a bit broader. Maybe not sort of have such a dichotomous view of things, but then it's rich coming from me because I currently have only thought of those two potential paths. So yeah, that's all I can really say for the moment.
And then I was just also wondering, like, throughout your math experience, what sort of like interesting classes or like fun like experiences have you particularly had?
So I mean, there was a lot. So there was a lot of stuff in secondary school or in high school, as I think it's called in the US. Mainly the maths Olympiads. Like I think that was basically what made me decide that I wanted to do maths at university. And I think I first got into maths because I was preparing for these Olympiads, and the UK Maths Trust, which is the organization that runs the Olympiads in the UK, they release these books on various topics that are assessed in Olympiads. So I bought their book on combinatorics, and I read through this whole book one summer and I did all the exercises. And then that's when I really thought, like, gosh, this is quite interesting stuff, right? There was in particular uh this technique in combinatorics called double counting, which is where if you want to count the number of arrangements of a particular setup or the number of ways of achieving a task, you kind of think about the problem in two different ways. And then as a result, because you're counting the same thing, you deduce that they must be equal. So you can actually deduce a lot of pretty famous results using these combinatorial methods. So for example, you might have heard of the formula for the sum of the first n integers. 1 plus 2 plus up to n is n plus 1 over 2. And then there's a similar one for the sum of the first n squares. And you can do that through algebraic methods or through induction or whatever, but you learn there's actually a combinatorial way of doing it, which seems initially completely unrelated. And I thought that was very interesting. So that was, I'd say, in high school. And then at uni, I think what I've really enjoyed, I say it's been algebra and analysis. So in analysis, it kind of starts off, you pick up where you left off at school. So you try to rigorously define concepts like continuity, differentiability, things that you took for granted in school. But then that was in first year. And then in the second year of my course, you start looking at things like topology and metric spaces and so on. And then I thought that there actually was a very you kind of because what's interesting about pure maths is that you kind of start off with the familiar scenarios and you go more and more general. And then I find that as you get more general, your depth of understanding of the very special case you started off with massively increases, right? So I can now look at the things that we discuss in real analysis, which is the analysis you do in first year, in a new light, because now that I've explored the more general case. And then that's a similar sort of thing in algebra. I did a course on ring theory this year, and you actually learn that a lot of concepts in number theory that you take for granted at school, like greatest common divisors, primes, divisibility, that kind of thing, is actually a very special case in a much broader setup. And I think it was very interesting seeing that in the ring theory course this year. So I'd say that's probably currently where my interests lie. And then, of course, there's probability, but at the moment, I've not been convinced that probability is actually worth caring about. I just think the problems are interesting and pretty straightforward. So, yeah.
That's pretty cool. I was also just sort of curious about, since I think you mentioned that you did competitions before, like math
Yeah.
Olympiads in the UK. I don't know, but like I was told that the American like math competitions aren't very like similar to what like being a math major truly is in like university or in college. I was just wondering like what are some similarities and differences between like math competitions and then like ultimately studying math as like a major?
Yeah, I think that's a good question. I because I too was a little bit misled in the sense that I thought that studying maths at university was just going to be doing competition problems all day, every day, and it would just be sort of sitting in a room and doing cool problems the whole time. But actually, it's kind of, I'd say, sort of halfway between in school where you're told these formulae and you do pretty routine rote learning questions where you just learn the processes and procedures. And then in the competitions, there's very little theory required, but you have to think in a creative way and so on. I think university sort of right in the middle, because in a lot of the exam papers, the first part of a question will be just reproducing results from lectures. So state and prove this theorem. But then the second part will be you have to apply it to a novel scenario and you have to think a bit outside the box. So I'd say that, yeah, it's not quite just doing hard problems, because you do have to just learn more maths and learn more results in order to be able to do the problems. But I'd say it's kind of a nice mix of both. Yeah. And I say both is actually very different to like research ultimately, because in that I get the sense that I don't have much research experience as an undergrad, but I get the sense that you've got to spend several months thinking about a problem, which which of course is quite different to say a 2-hour exam or something like that.
I see. And then sort of to like end off, I just wanted to ask if you had any pieces of advice, recommendations, suggestions, honestly, anything for students who are interested in pursuing something math related in the future.
Yeah, so I'd say that it's actually it's very simple to phrase. You just want to do as much maths as possible. You want to just be as good as you can be at maths. You want to have as much exposure to as many ideas as possible. You want to have thought deeply about a lot of difficult problems. And I think if you make that your goal, you can't really ever go wrong, because if your goal is to say get into a particular university or so on, then that's going to come as a consequence of just being very good at maths. And so I'd say things like competitions, books, that's the direction you want to be aiming at. But also you want to, I think, eventually develop a deeper sense of what you actually care about in maths, and then trying to focus on that as much as possible. And yeah, I'd say because I think it's often quite difficult, because in the US I get the sense that it's really about breadth, not only in the university but also when you apply. Like I think you want to do lots of extracurriculars and so on, right? And I think that's quite different to the UK, where they care more about focus. But I would say so. I would say that's really important to just to focus intensely on fewer things, because you end up just being better at those things, and not to try and spread yourself too thin. I'd say that's my advice.
Okay, sounds good. Thank you so much for talking with
Yes,
me and sharing your experiences. It was absolutely fantastic. Thank you.
that's okay. Thanks so much.